right, welcome to what hopefully for you will be the last stats recording. So today it is going to be on linear regression and your calculator. So let's go ahead and begin. For linear regression, you're going to be doing it in your calculator, which is a fantastic thing for you. It is when you have what they will call bivariate data, which is paired data, which means that there's two pieces of information for each individual. So that's very important to keep in mind. There are two separate pieces of information, two separate measurements, two separate in your data set. So that's why it's paired, and the bivariate, it just literally means two. So there's your pair right there. Your goal when you do this, hope that you have a linear relationship between this data. It's not always the case. Obviously, when we're doing a unit on linear relationships, it probably will show up and end up being the case, but it doesn't have to be the case. And there are 5 steps, and we're going to hit each of these 5, but this might be what you kind of want to jot down if you're taking some notes. Step 1 is you are going to actually take a look at your data in a scatter plot. You plot your data in a scatter plot, and then you actually look at it in step 2 and decide whether it actually appears straight or not. If it is, then you go forward. If it does not appear straight, then there would be other things mathematically to do. Step 3, if it looks straight enough, you actually run linear regression, which is going to create an equation of your best fit line for your data, and your calculator will do that. And again, it will be an equation of a line. Step 4, after you have your equation of your line, you will evaluate several aspects of it, including the slope and the y-intercept, and there will also be something called the correlation coefficient that you will also have to interpret, and then you can use your model to make predictions. So those are our 5 steps. Before you begin, when you have paired data, you must decide which variable is your explanatory or independent variable, and which variable is your response variable. It's very important to identify the difference between those. Your explanatory is your independent or your X, and the response is your dependent or your Y. And the explanatory will be your input, and the response will be your output. So you'll be making predictions about your output based on what you feel is driving the data. And sometimes it's easy to identify what is important, what is the explanatory versus the response, and sometimes it isn't. If I had all of your SAT or PSAT scores, and I had your math score and your verbal score, English score, it would be difficult to decide which of those was the explanatory versus response, but some things are easier to identify, and usually they'll actually give you your data, so you won't have to make that decision, but you need to think about it. So we're going to look at a couple of IB classes. These are actually data finally from Miss Taylor's classes. I'm not leaving you guys out. And we're going to compare height with shoe size. And so take a second and think about what you would make as your predictor variable if you had height and shoe size. So take a second, pause. All right, hopefully, and you may disagree, but hopefully you felt that maybe height would be a better predictor of shoe size than shoe size predicting height. So here's a table of data from 2 of the IB classes. And again, this time I decided to separate it between females and males because they're different shoe sizing for women and men, so whatever. So that made sense to separate the data to have a clean comparison. So these are all of the females from those 2 classes in giving their height and their shoe sizes. So what we'll do is we will put this in our calculator, and we'll make a scatter plot, and then we'll look at it and see if it's straight enough. So if you go to your graphing calculator, you would put the data in the same way. So actually you wouldn't you just hit stat, and you would go over to edit, because you want to, or don't go over, you just hit enter. You don't need to go over on this one. You just hit enter. And I've already gone ahead and put all of this data in list 1 and list 2. It's a lot of data, so if you need to go take a second and go back and pause and put the data in, you can. I've already done it. And then if I want to graph it, I go back up to our regular stat plot screen where we've done all of our other graphs, and I have to come down here and turn this one off because I was plotting something else earlier. And then I'll come up here and I will go to plot 1, and I will turn plot 1 on, and this first graph is your scatter plot. And so you're going to choose that, and then once you've chosen that, you want to come down, and your X or explanatory for me was in list 1 and my response was in list 2. And then again, you hit zoom 9. I'm going to make sure that there's nothing in my y equals, and there was. So I cleared that out. So I'm going to go back and I'm going to hit zoom 9, and there's our scatter plot. And if I go back here, is the scatter plot, and we want to look and say, now that I have it, does that look straight? Does it look linear? And I would say it definitely does not make a perfectly straight line. So now I have to talk about assessing the level of strength, and then I have to figure out how I can quantify that strength. There definitely is an upward pattern going on here. So we're going to talk about how we can determine how strong of a relationship this is. It's definitely not going to be a perfect straight line, but that would be weird if it were perfect straight line. So we expect some variation in there. So generally, if you can envision, I'm going to kind of draw it on here, even though I'm going to do it in the same color. Like I can sort of draw a line straight through all this stuff and say, okay, well, there's sort of this pattern. This is all a little bit away from it, but not a big deal. So let's talk about how we can discuss this variation or spread that's not actually near the line, and what does that mean in terms of how strong our line is. So that is determined and calculated by a mathematical value, and IB likes to use all of the adjectives that explain it, which is Pearson's product moment correlation coefficient. Most of the time I will just call it the correlation coefficient, but the official name is Pearson's product moment correlation coefficient. So if you even just hear the word correlation, it's usually referring to the correlation coefficient. And it is a number between -1 and +1, and that's it. Those are the only values it can take. A score of 1 or -1 are perfect linear fits. 1 is a perfectly positive linear correlation. Negative is a perfect negative linear correlation. And I'll show you some graphs in a minute. The closer you are to +or-1 numerically, the stronger the linear correlation is. So like a 0.8 or -0.8 would be pretty strong. Negative would be a strong negative correlation. And for example, 0.3 would be fairly weak correlation. And -0.5 would indicate that there is some sort of a relation or correlation, but not excessively strong. So this is kind of visually what we're talking about. This one right here is a perfect line, and that would be a correlation of -1. Everything is actually right in line. And this is the positive one, meaning that it is perfectly straight up and down. And then these two are, you can see, they are not perfectly lined up. So if I kind of draw a line through this and a line through this, you can kind of see how these x's are a little bit closer to the line. That's going to mean it's a stronger relationship, and I'll have a higher correlation. These are a little bit farther spread out, but it's still a general pattern that would have a negative correlation. And so if we were to think about our graph, it's sort of in between these two, more or less. And what you don't want to see with linear regression is this. This is a correlation of 0, which means if I were to draw a line of fit, I would have to draw it right like this. That is a horizontal line, and that is indicating that there is absolutely no relationship between the two variables on x and y. So those are sort of the visuals to give you an idea. And ours, again, was not this strong. It was probably a little bit closer to this one. Visually, it appeared to be. So that indicates that it's not an extremely strong one, but it's kind of strong. So we would say from our graph, yeah, it's not great, but there appears to be definitely some sort of positive association here that I could fit a line through this and it wouldn't be completely out of my mind. All right, excuse me. Woo. We're now going to run linear regression, step 3. So we've scatter plotted. We looked at it, we felt straight enough. Now we're going to run linear regression, and that's going to give us all of our slopes, y-intercepts. It's going to actually give us our model. So before we do that, you need to do a couple things to your screen, to your calculator. So if you have a newer calculator, you need to hit your mode button. And you can see there's a whole bunch of stuff on here, but down here is stat diagnostics. And stat wizards, your stat wizards is probably on, but your stat diagnostics may be off. So you need to come down all the way down here and click over here and make sure you select that your diagnostics are on. Now, when you went to mode and you scroll down and you didn't have all of this fantastic stats stuff, you don't need to worry. I'm going to show you how to do that as well, but you need to do it. It's a little bit more complicated. So you need to go to your catalog. So you need to hit the second 0 button, and this is everything your calculator does. Now we want to jump to the diagnostics, so you want to hit your alpha and your D button, which is right here by x -1, your inverse function, and that'll jump you to your D's. It didn't really work for me because I think I was already on it. There we go. So these are all the D functions, and now I'm just going to scroll down till I find diagnostics. There it is. I choose diagnostic on and I hit enter, and now my diagnostics are on. So that's a requirement for you before you run linear regression. And if you clear your memory or anything in between, you need to go back and do that again. So now we're going to actually run linear regression, and to do that we hit stat and we go over to calculate. Again, there we are, and you notice there's linear regression right there. If you take AP Stats next year, you may use this linear regression number 8 down here. They both give you an equation of a line. They just change the position of the slope and the y-intercept. So IB typically does it with this number 4. So we choose 4. My data, my explanatory data is in list 1. My response data is in list 2. I do not have a frequency list. I am going to show you a little trick here. I do want to put my regression equation into my calculator, so you may want to watch this and back up and go over it slow motion if you need to. I want to hit the vars button, and I want the y var, so I go over to y vars and I choose enter because it is going to function, and I want it to store my equation into y1. And so what that's going to do is where you usually graph and y equals, it's going to put my regression equation right there for me so I don't have to retype it. Once you're done with that, you come down here and you hit calculate. Kabam. There you go. You get all this output. And now I'm going to come over here, and that is what we got for our linear regression output. And this, if I hit graph, it would automatically put my regression line right through the middle of my dots. This is the line of best fit, and that's what it would look like. So let's talk about this very quickly. A is your slope. There it is, 0.237575803. B is your y-intercept as a -7.965453591. R squared is called the coefficient of determination, and we will not use that much in IB, so you don't need to worry about that. If you take AP Stats, you will be dealing with the R squared value. This is the correlation. R is your Pearson product moment correlation coefficient, and it is telling us that it is positive, and we can see that from our blue line going uphill. And 0.63 again was a little bit closer to that 0.5, not quite as close to that 0.8 from the visual, and we kind of could tell that from our graph anyway. So this is, it's not really super strong, but it definitely is a positive association going on. So that's our calculator output. We've run linear regression on our calculator now. You've seen it, you've gotten it. And now we can actually write our equation, which in AP Stats in particular, you always have to put a hat on your y, which indicates it's a predictive model. And you put your, actually write the slope, I've rounded, in front of x. My y-intercept is negative, so minus. If I hit the trace on here so you could see what the scale was over here, because this is your y-intercept is negative 7.96, and you might be like, well, wait a minute, but that's not negative, but that's because this is at an x value of 58. So the x value of 0 would be way over here, and that line is going to continue going down and eventually end up being negative. So there is our actual equation. That's your output. That's what you want to end up with. This is going to be your information that gives you your equation. Be careful, because sometimes on the IB exam it just says list your A and B value, then you just list them like this. Sometimes it wants you to write the equation, then you have to write it like this. So you got to pay attention to what they ask for. All right, step 4 is to evaluate each of these. And we are running out of time, so I'm going to pause this and we're going to have to go to video 2. Sorry, video 2 coming up in a minute.